Let's have a look at the following data. We have two variables, 1, 2, 3, 4, 5, 6, 6 values for A, and the B variable we have also 6 values. Let's add a data and statistics page, and we can plot A on the x-axis and B on the y-axis. So if we were to do a linear regression here, we see that all the points are pretty close to the line. So if we have a look at the residuals, the sum is a very low value. Okay, so it's interesting sometimes to see how good the correlation is. That is how close all the points are to this line. So there's a way to measure that. If we look at this picture, here to the left we see a perfect positive correlation, because the slope of this line, if we were to do a regression here, all the points would be on the line. So this is a perfect positive correlation. The value would then be 1 because it's positive, and 1 is the highest value. Then we can see this example, the points are a little bit more spread out, but still we can see a tendency that we would have a line in this direction, so it would be, the slope would be positive. Closer to 1, but not exactly 1, because they're a little bit spread out, but still a very high positive correlation. Here we have some other values, even more spread out. We still see a line going through here, but they're more spread out, so we have a low positive correlation, so a value closer to 0. And when we have correlation coefficient that is 0, that means that we have no correlation at all, because we can't see if the line is going like this, or like this. Positive or negative slope is complete chaos. Then the correlation coefficient is 0. So when we have a perfect negative correlation, the value is -1. We see here, if we were to do draw a line here, all the points would be on the line. Here we have a value close to -1, so it's -0.8, because we still see a line here. The slope is negative, that's why we have a negative value. So if you look at all these examples, you get an idea of how this coefficient is working, the correlation coefficient. So when we have a positive slope, it's positive value. When we have a negative slope, then we have a negative value. And when it's perfect, then it's either 1 or -1, or very close to 1 or -1. When we have basically no correlation, a very low correlation, it's close to 0. So let's get back to our example, and there's a way to find out this this correlation coefficient. We're just going to go, when we have this table with the data set with two variables, we just go to menu, statistics, and linear regression. And then the X list is going to be the A variable, the Y list is going to be the B variable. And then we can just scroll down, everything is fine, click OK. Here we see that the linear regression model equation would be mx plus b, so the m value would be 1.02857, and this b value would be 5.19 more or less. If we scroll down a little bit, we see the r value is very close to 1, so we have a very high positive correlation coefficient. So once again, if we look at this line, the slope is positive and all the points are very close to the line, so it's as close, we're very close to perfect positive correlation. So here we have the R value, it's very close to 1. Let's change a couple of these values. So we get a different, let's see, we're gonna change this to 19, 6 to 9, and 10 to 20. Now let's have a look at this. They're spread out, the sum of the residual squares are much higher, and if we go here, we can have a look at the R value, and it's 0.53. So the correlation coefficient is between 0 and 1, so not very good correlation, because the points are very far away from the line, so they're more spread out. So this is how we may measure the correlation coefficient.